really love holiday lighting, and so I picked up some of these HomeStarry. I don't know, I just think HomeStar Runner, the website from the early 2000s. But anyways, I think that they come in strands of 6 foot. I think this is a 6 foot strand with 33 LEDs. And then I think there's a longer set of 12 feet. And that has 66 LEDs with the shorter strand. They work quite nicely. Comes with a remote. There we go, turns them on. They get quite bright. For most of these, I'm fine running them on batteries. It has a timer function, so you can hit timer, it blinks, runs for 6 hours, turns off, and then comes back on for 18 hours later. And I got the inspiration for this video actually from watching BigLive.com, because he was talking about some Christmas lights, or these are also called fairy lights if you look at them on the listings, that don't have a crystal in them. They use the internal RC clock, low speed, low precision clock on the little non-identifiable chip. That's fine, but what happens is I have actually 3 or 4 of these around the windows in our place, and it'd be nice if they'd be actually timed to one another. And what he was describing was the clock drift that occurs on these RC oscillators as opposed to a crystal over just a couple of days. And so I'll link to his video here to take a look at that if you're curious about what that is. But what I found on these is that if you flip it over on the back, there's a crystal oscillator right there on the back. And so I was kind of excited about that these, despite being, I think it was $12.99 US dollars for a 2-pack of these, that it came with the crystal. And I had noticed that the 3 of them that I have, or 4 of them that I have, about once a week I replace the batteries, turn them on, hit the timer, and then they're all basically within IR range of each other. They just all blink, and then within maybe seconds of each other they come on, even after 5 or 6 days into the battery discharge. I wanted to take this apart, kind of look at what is going on with the circuitry here that might be a little bit different from the ones that he looked at. And then the really big thing that I want to do, hopefully, is to get enough information about this to drive one of these using generic USB adapter. I'm curious. Let's dig in and see what we can find. So first thing I'm going to do is remove the batteries with a screwdriver. That's the best way to remove batteries. Now these particular, it seems like they all use these enclosures that are like, they tout them as like IP, I don't know, IPX5 rated or IPX6 rated. It's just a box with a seal around the outside, which is kind of nice. The button's also sealed. 2 screws holding this in. I think it just holds the circuit board back. And I'm not sure if this is actually sealed. But we'll hike that off of there. Ooh, is it glued down? No, it's not. I can see an air gap right in between there, so this, I think, comes right out. But it is held by something on the other end. I think it's just glue. They just hot glued. Ugh. That's gonna make trying to get in there fun. But I do like the fact that they actually use an actual microtack switch and not like a PCB dimple switch. Hot glue is just not making me. I'm not gonna ever use this thing outside. I think they hot glued it to seal it. So I'm just gonna pull the hot glue off. I don't think there are any components underneath there, but if there are, we will find out if we accidentally rip them off the board. Oh, that is really, let me get pliers. I'm going to release the screw for the PCB, just so I'm not putting any strain on this little tiny PCB. There's a little plastic aligning guide. I'm not sure if that's heat staked too. It looks like it's not, but we'll find out. Let me see if I can just get... Wow, they use a lot of hot glue. I don't want any water getting in there. Yeah, it's hot glued for the wire. It gets the job done. Oh, it is also holding the... You know what I might do? I might just clip this wire, pull it out, and I can resolder it later. It's easier to do this with the color, or with the non-color ones than the color ones, because the color ones have 4 wires going in. So I'm going to cut that off. It wants to come out. Oh, I think I see what's holding it. It's just right here. It's just with the hot glue. It's not the hot glue itself, it's just wherever the hot glue adhered itself to. And it's probably going to be mostly the enclosure. This terminal's really... There it goes. Okay, well, might require a little bit more finessing to get it back in there, but the board is almost out. That is nice. It is ready. That is definitely lead solder. This is not rose compliant. That came off way too easy at a low temperature of 575 degrees Fahrenheit. I just wanted to get a good idea of what's going on this board. There's really nothing. It's a one-sided board. You can see on the back, there's the crystal. I'll flip the crystal back just a little bit so we can, unless it's glued down. It's not glued down. It has nothing on it, but I'm pretty sure it's the 32.768 kilohertz crystal. And got a few components on the front here, not much. Now, mystery chip, because there's no markings on that chip anywhere. Mystery 8-pin chip. Not surprising. This, I believe, is the IR receiver sitting on the board here. Let's just kind of clip these off, and then I realized that I'm probably going to need a load. It looks like when they make these, there's like a starter lead here. It runs all the way, maybe, I don't know, it's about a little less than a foot. And then it's terminated, and then it goes into this magnet wire. It's enamel coated wire. It's magnet wire, meaning it's usually meant, this type of wire is usually used in transformers or motor windings, where you have turns that are sitting next to each other, and you don't want them to short because you're trying to create a magnetic field. And you don't want just a bare wire touching a bare wire would be a dead short. So there's a coating of enamel over these wires that basically provides a level of insulation. So that's why these wires can touch, and you don't get a dead short across the string of lights. Now, if you were to take a blade or something and you were to kind of scrape away, or you were to take like a cigarette lighter and heat this and burn away the enamel, you just short it. Then you'd be able to easily short it. So, but it's a pretty neat package because it's cheaper. They don't have to put any kind of PVC, insulated wire or whatever on here, and they mount the LEDs right onto the wire. So it's I guess in some ways more economical and more, maybe slightly more environmentally friendly because there's less materials. I'm going to solder this back on again. We are at about, I think this is no better than 26 gauge. just so we can have a visual indication if things have gone wrong. I'm going to tin these and then I'm going to clip them. Cool. We'll just tin the whole thing. Okay. This is negative, and this is positive. Good. Everything's kind of in view here. Awesome. All right. I think it's on, but I think it might be in its dancing mode, so let's get it into mode 8, which is constant on, DC. And then we'll just see which is which here. On. I haven't dead shorted the batteries. The battery should be 385, 385, 385. Okay, cool. Hey! That is not a very clean. Let me flood a tiny bit of more solder on there. Oops. A voltage across that. I think I just answered my own question. I think it's because it's PWM'd. Ta-da! There we go. Awesome. Okay, so these lights, even in their fullest brightness, I mean, if I shake them around a little bit, you probably can see on the camera that they're flickering, right? So the chip, let me see if I can make sure I'm getting this clear. The chip's got a pin on it somewhere that's pulse width modulating the output at a particular frequency, probably somewhere in the kilohertz range. Also, this has, I think in some way, these LEDs they're just wired in a particular way that they're like one is in reverse polarity of the other, and so it drives actually, we can test that right now. I'm wondering if that's what it is. They just reverse each of the LEDs, and then the pulse width modulation is just going back and forth between positive and negative fast enough that you don't notice it. But let's see. Let's see if the DC shows us anything. There we go. Negative. Positive. There you go. That's pretty cool. Each LED is in reverse polarity of the other. And so how they get them all alight when you put them on the all lit mode is the pulse width modulation is swinging back and forth between positive and negative to give you the effect of all these LEDs lighting up at the same time. So that's pretty cool. And there are a lot of lights that you can buy that have 2 LEDs per actual package, and one LED is biased one way and it's like a white LED, and then another LED is biased the other way and it's color. And if you push the button on the controller, they'll light up white. Press the button again and it'll flip the polarity, and then all the color LEDs come on. It seems like these operate in a very similar fashion, just so that you get effects on the LEDs as opposed to different colors. But what I'm curious about is like what the components are, and can we get 5 volts across this and not blow this thing up? And so it looks like what we've got is the little controller, some capacitors popcorned around to kind of provide support and decoupling, the infrared receiver, and this I believe is the MOSFET or a FET, or maybe it's just a BJT transistor. Maybe it's just a transistor. that is just turning on and off the output. But a mystery component, I'm going to fold you back down. So you can see it's a 3-pin device. Oh, it has marking on the top. It's LFN. So my guess is that we can drive this off 5 volts. So just gonna hack the end off of this. So I'm just gonna go with a pretty large gauge. I'm gonna go with 18 gauge just to pull off the outer covering. And then you'll get your 4 wires. Now, we don't want the data wires. We're not gonna be using the 3.3 volt stuff. So I'm just gonna clip those a little shorter so that we just don't get them out of the way. And then we're left with hot, kidding, positive and negative. And that is generally like 26 gauge or 28 gauge. And I'll just strip that a little bit. And beautiful copper. And then what I'm going to do is, you don't want to do this and plug it in while the batteries are still in here. You can if you want. It'll just start charging the batteries. If you have alkaline batteries in them, they're going to probably not be very happy. My recommendation is to take the batteries out, because it's not a good way to even charge nickel metal hydride batteries, because these are all in series. So you're just basically applying 5 volts at the end of this thing, and you're not going to really charge the batteries. Don't leave the batteries in if you're going to make this modification. Clipped off the data leads just to keep this clean. And I sort of nicked the positive side, but we're just doing this for a test, so it's going to be plugged into one of my trusty battery banks that I've shorted out several times, and it's recovered with no problem. Let me tin these really quick. I'll clip them a little bit. So we're going to tack you on there. Melted a little bit of the insulation. Tack you on there. Well, I'm going to flood it with a little more solder because it's not really, it's resting on top of the connector. I'd like it to hold a little more better. A little better than that. A little more better. There we go. Perfect. All right. Clear out the smoke. Okay, so we have the USB. Just gonna go get a battery pack and then plug it in and see things go bang. So, power's on. Look at that. Look at that. Beautiful. Drive them up at their highest voltage. I'm just going to check what our voltage is coming in. 5.06. Good. Might run these for a while and check the temperature on some of the components. I come back a little farther to not, and I just wanted to see that diode, I'm sorry, not diode, the transistor. I mean, I don't know what it normally is, but 33.5, 34. I'll set it up on its max mode, so you can see once I'm done ranging it. Nah, nothing's getting above. Just by the, that's interesting, by the traces. Going to the LEDs is around 40. That's the highest it's getting up to, is 40. As you can see by the max, the lower number, because now it's just measuring room ambient on my table here. But yeah, 100 degrees Fahrenheit is a little warm for that area. Let's pull out the USB measuring device and see what kind of current we're pulling. So they are on their maximum brightness. And just going to unplug these. 5.1 volts. We'll plug this in and see what we get. Interesting that when it's off, no timer or anything, it's drawing, according to this thing, nothing, no current at all. So turn it on, and about a half a watt, 5.1 volts. Let's turn up the brightness even higher. Oh, look at that. So almost up to 1 watt. So when it's up to its maximum brightness, it's that's quite it. So its default brightness is like about 4 steps lower, about 5 steps lower. So you can see how that just coming down 5 steps from its maximum brightness on the remote, it cuts the power in half. That's pretty amazing. So if you're looking for runtime to get more life out of the batteries between charges, wow, just back down the brightness by a few steps. But we crank it up all the way, and the input coming in is almost 1 watt. So I guess, yeah, right across that spot there. These are generally 85C or 105C boards, so you're nothing really to be concerned about. Pretty cool overall. I mean, we got this thing running off a 100 watt hour pack. I mean, you can probably drive this. The internal discharge of this might actually exceed the loading of the LEDs. That's why I'm hooking this up not for a battery pack, but hooking it up for a an ice cube charger or something like that. That can 1 watt is plenty for it. Also very interesting to see the behavior of not only the LED construction, but how the power consumption varies. Let's just go down to its lowest level. This is the very lowest, 1/10 the maximum. Wow, it's pretty interesting. And you can see them as screwdrivers fall off my bench. Very interesting. So yeah, I would say these really handle 5 volts. Maybe I'll do a follow-up video after the end of the holiday season and see if they survived. So until then, thanks for watching and happy hacking.